Hello children, today we will be discussing about the trigonometrical ratios of standard angles. This is chapter number 2 in trigonometry, that is chapter number 18 in your textbook. So it is the continuation of the first chapter of trigonometry. So you are supposed to know all basic ratios. I hope you have learned all the basic ratios. So it's a continuation. So we will be discussing mainly about here the trigonometrical ratios of standard angles. Now what are the standard angles? Standard angles are 0 degree, 90 degree, 30 degree, 60 degree and 45 degree. We will be discussing the trigonometrical ratios of all these angles. See, for example, like sine 0, cos 0, tan 0 and all trigonometric values, trigonometric ratios based on 0, even 90, even 30, even 60 and 45, and you are supposed to memorize all those values. And those values you have to substitute and then you have to evaluate. That's the thing we will be doing in the exercise. So first of all, how the values are coming up, all these values I will show some derivations. So these angles. Okay, so first of all I will be discussing about 0 degree and 90 degree at a stretch. So I will make support of coordinate geometry. Coordinate geometry we know x-axis and y-axis. This is origin. If I take a point here, let it be the point I am taking 1, 3. If it is 1, 3 means this height will be 3, that is y coordinate, and this one will be the x coordinate, that is 1. So if one point is given, the corresponding x coordinate and y coordinate what it represents, that you know that this basic idea is required. And plus one more thing, unit circle. What is a unit circle? Unit circle means a circle whose radius is 1 unit. So what I am going to do, first of all I will draw a unit circle with the origin as the center. A circle with the unit, 1 unit of the radius. I am going to draw a circle with 1 unit. Yes, 1 unit means it can be anything, 1 centimeter, 1 meter, anything like that. So I am drawing a circle of unit radius. This is known as unit circle. It's a unit circle. In this unit circle, naturally unit circle means radius is 1 unit, so this is 1 unit. Even this is 1, these are 1. Again, in x-axis, y-axis, we know this is a point on the x-axis. Naturally, we can write the coordinates of this point. This point will be 1, 0. Since x is 1, y will be 0. It's a point on the x-axis. And when it comes to here, it's a point on the y-axis. So naturally, this point will be 0, 1. Now, if it comes to here, it is in the negative direction of x-axis, so this point will be minus 1, 0. Even if it comes to here, it will be in the negative direction of y-axis, so 0, minus 1. Simple basic coordinate geometry applied. Now, I am taking a point on the circumference of the circle. Circumference of the circle is a general point. So here I am taking a point, let it be x, y. We don't know actually what is its value, so just x, y. It's a point on the circumference of the circle. Now, if I join this with origin, naturally this is the radius of the circle, it is of 1 unit. Radius is 1 unit, I already said it's a unit circle. Now, another vertical line, I am drawing a vertical line. With respect to this coordinates, vertical line. Naturally, this point is x, y. I told in the very beginning, if it is x, y, x coordinate will be here, the distance, this distance will be x coordinates, and this height will be y coordinates. Alright, it's just coordinate geometry. So far, what I have done, only coordinate geometry. Now, here I am taking this radius, this radius is making an angle with x-axis, let it be this angle is theta. Okay, this radius is making an angle theta with x-axis. Here if you observe, now you can see a right angle triangle, you can see the right angle triangle. In this right angle triangle, I am applying the trigonometric ratios. That is, first of all, I am applying sine theta. If I apply sine theta in this right angle triangle, sine theta means we know opposite side by hypotenuse. That is y is opposite with respect to theta is opposite side is y and hypotenuse is 1, so it is y by 1. This implies what I am getting, y is equal to sine theta. That means on this unit circle, whatever be the y coordinate will be always represented by sine theta. Y coordinate will be sine theta. This theta is the corresponding angle. Wherever it goes, theta is the angle, so y is equal to sine theta. This is one result I am getting. The same way, if I apply cos theta there, cos theta is adjacent by hypotenuse, so it will come in x by 1. This implies x is equal to cos theta. That means if I take any point on the circumference of that unit circle its x coordinate is represented by cos theta and y coordinate is represented by sine theta. This is the general conclusion we can make it. If any point on the circumference of the circle, of this circle, of unit circle, okay, circle with the unit radius, its x coordinate will be cos theta and y coordinate will be sine theta, where theta is the angle made by that particular radius with the x axis. This is the general conclusion we can make from this diagram. Now we will come to different situations. Suppose this is the radius. This, if it falls on the x axis, at present it is theta degree. If it falls like that, if it comes down to x axis, naturally the angle will become how much? This theta will turn into, originally theta it was, and theta is slowly decreasing and it falls on to the x axis. Naturally the theta becomes 0 degree. Theta becomes 0 degree, this theta becomes 0 degree. If it is on the x axis, this theta is 0 degree. Therefore, in place of this theta, I can put 0. If I put 0 here, that is sine 0. Corresponding to 0, you can see the coordinates here. This was corresponding to theta. This xy is corresponding to theta. Corresponding to 0, the coordinate is 1, 0. So, and y value will be always sine theta, y is sine theta, so here y is 0. Therefore, sine 0 will be 0. Sine 0 is equal to 0. Okay, y value already I said y stands for sine of that angle. Now, x stands for cos, so cos 0. If I go for cos 0, it is the x coordinate, cos 0 is x coordinate, so x coordinate here it is 1, so cos 0 it is 1. Now if you know sine and cos, it's a combination only tan. Tan we can say tan 0 is equal to sine 0 by cos 0, 0 by 1, 0 by 1 it is 0, tan 0. Now other functions are all its reciprocals. So for example, reciprocal of sine it is cosec. Cosec 0 is 1 by 0. 1 by 0 is not defined. We will keep it as 1 by 0. And then the reciprocal of cos it is sec 0. Sec 0 will be 1 will come its reciprocal. And reciprocal of tan, that is cot 0 will be 1 by 0, that is not defined. So basically if you know sine 0 and cos 0, sine 0 and cos 0 if you know, you can write down all other trigonometric ratios, So corresponding to 0 degree, you can see the coordinate is 1, 0. So it is better to remember like this: 0 degrees coordinate is 1, 0. 1, 0, and this x will be always represented by, x is represented by cos and y is represented by sine. So if you remember 0 degrees coordinate 1, 0, it is very easy. Now this is about 0 degree. It is about 0 degree. Now in the same diagram, suppose this theta, originally it was theta. This theta again if it rotates and if it comes here, at present the angle it is 90 degree. See, originally it was theta and I am increasing and it comes to here. So naturally this y axis it will come here 90 degree. So this is the 90 degrees position. Corresponding to 90 degree the coordinate is 0, 1. Corresponding to 90 degree the coordinate is 0, 1. 0, 1 corresponding to 90 degree. Naturally cos, x stands for cos, so cos 90 is 0. Cos 90 is 0 since x stands for cos. Cos 90 is 0, sin 90 is 1, and other ratios we can make out from that. So this is about a 90 degree. Now if you look at the, again this, if you look at, that is not in your portion, if you look at this diagram, this, if it rotates, if it is 0, if it rotates and if it falls here, at present we can see here it is 180 degree. This is coming 180 degree and 180 degrees coordinates. 180 degrees coordinate is minus 1, 0. So naturally cos 180 is minus 1, sin 180 is 0. Since the cos stands for x coordinates. Again if you make a rotation, if you rotate and if it comes here, at present the angle is 270 degree. 270 degree. So 270 degrees coordinate is 0, minus 1. So cos 270 is 0 and sin 270 is minus 1. Again if you make the rotation and if it falls to here, it becomes 360 degree. 360 degree, 360 degree is same as 0 degree it comes. It is 1, 0. So that way we can go for all multiples of 90 degrees. But in your portion you are supposed to memorize only 0 degree and 90 degree. So if you memorize only the coordinates, 0 is 1, 0, only bring the diagram in your mind. 0 degree is x, it falls on x axis, so it is 1, 0. And then 90 degree will be its reciprocal, its reverse order, that is 0, 1. So this is the case for 0 degree and 90 degree. 0 degree and 90 degree. Now I will go to the next standard angle, 30 degree and all, 30 degree and all, okay. So that is also I will explain the same concept. I said already x stands for cos, y stands for sin with respect to angle. So with the help of that I will be telling about 30 degree and even 60 degree also I will be saying with support of that. See again, axis I am drawing it, x axis, y axis. This is origin. I am making a unit circle. I am making a unit circle with origin at the center. I am not going for the whole circle, only I need a semicircular region. So I am going for only that much. I don't want the whole part. Alright. As a unit circle I have made. Unit circle means radius is 1 unit. Alright, here I am making one of the radius. See, I need 60 degrees, so based on that I am drawing a radius. This is 60 degree angle. That radius is 1 unit naturally. Here I am drawing a vertical line that is perpendicular. Then only you can go for trigonometric ratios. So 90 degree I made. So this is 60. This is 90. Naturally this will be 30 degree. Alright, this will come 30 degree. Alright, this is, we know this is also 1 unit, this is also 1 unit. Now if you look at this triangle, these triangles, if I join here, see this is 60, these two are 1 unit, so it is isosceles we can say. So this is 60. Therefore, the base angle also, if you calculate, base angle also will come to 60 degrees. If I calculate, this is 60 isosceles. With the help of isosceles, if I calculate the base angle, this angle and this will come 60 degree. Naturally, it is an equilateral triangle. This is an equilateral triangle now we can say, because this is 60 as well as isosceles. So it is equilateral triangle. So in equilateral triangle we know one more thing. If I draw the vertical, that is if I draw the altitude, it will bisect the base. The whole, this is 1 unit. So therefore this portion will be half and this is also will be half. Since the total I taken it as 1 unit circle it was. So this is half, this is 1. Now we can find out the height. By Pythagoras theorem. Okay, if I find out the height by Pythagoras theorem, that is the height I am finding out, that is h square is equal to 1 square minus 1 by 2 square. This is coming 1 minus 1 by 4, it is 3 by 4. So h is equal to root 3 by 2. So that means this height I am getting it as root 3 by 2. I got the height as root 3 by 2. Now we can say the coordinates of this point. See, x is 1 by 2, x is 1 by 2, and height, that is root 3 by 2. I got the coordinates of the, that is 60 degree radius. It is coming 1 by 2 root 3 by 2. Now from this we can see easily, we know, I said already, cos stands for x coordinates, so cos 60. From the diagram we can say cos 60 is equal to 1 by 2, cos 60 is x coordinate, and sin 60 is the y coordinate, that is root 3 by 2. The other ratios like tan, if you want tan 60, from this we can say tan 60 will be sin by cos, root 3 by 2 by 1 by 2, so 2 will get cancelled, it is root 3. And other ratios we can find out by its reciprocal. That means 60 degrees coordinate is 1 by 2 and root 3 by 2. If you remember the coordinates of 60 degree as 1 by 2 root 3 by 2, all other values we can find out. So that is for 60 degree. So 60 degree I said. Okay, now we will discuss about 30 degree. 30 degree I am drawing on radius here with the 30 degree. 30 degree angle on radius. This is of unit circle. Okay, unit circle already we know, and here one perpendicular I am drawing it. Perpendicular. This is 30, so naturally this will be 60. Since 30 is 9, 60, 90, okay. Now here if I go for one more construction like this, one more construction if I make, this is also 1 unit, this is 1 unit. So this one means from here to here it is, alright. Now if you look at this, these two triangles we can do it congruent. If it is congruent, okay, this is 30, this will be 30, so naturally this will be 60. 60 at the same time it is isosceles to equal, and this is 60, 60, so it is equilateral triangle. Here also if you look at this complete triangle, it is equilateral triangle. Equilateral triangle, so this is 1, this is 1, this full, this is also will be 1. Naturally this will be in equilateral triangle, altitude will bisect the base, so this is 1 by 2. Since the whole length is 1, equilateral triangle. Now this we can find out again by Pythagoras theorem, just now applied by Pythagoras theorem. This height is coming to root 3 by 2. By Pythagoras theorem, I can find out this height from this small triangle. If I look at this triangle, I can find out this base, it's root 3 by 2. So now with respect to 30 degree, we can say the coordinate, this is root 3 by 2, that is x. So this is root 3 by 2 and height it is 1 by 2. That is x coordinate and y coordinates I call. So now naturally cos 30, from this we can say cos 30 stands for x coordinate, that is root 3 by 2, and sin 30 is the y coordinates, that is 1 by 2. And if you want a tan, sin by cos, so 1 by 2 by root 3 by 2, so it is coming 1 by root 3. That is tan 30. All other values we can find out from here, so 1 by root 3, and then other reciprocal ratios we can write down from here. So with respect to 30 degree, the coordinates are root 3 by 2, 1 by 2. But with respect to 60 to us, 1 by 2, root 3 by 2. Just they are interchanging it. So coordinates form, if you memorize, it is very easy. 30 degrees coordinate is root 3 by 2, 1 by 2, and 60 degrees coordinate is 1 by 2, root 3 by 2. So that way we will get 30 degree. So 0 to 0, 19, 30, 60 is over. Everything I explained with the help of unit circle. Now we will say one more is left over, that is 45 degree. 45 degree case also we can do it by same method with the help of unit circle. 45 degree case. That is also I will show you. 45 degree case. Again a unit circle we need. With the support of unit circle I am deriving it. Unit circle 45 degree we need, so I am making 45 degree angle, that is 45 degrees radius 1 it is. Here I am drawing a vertical line. 45 degree case, so I am making 45 degree angle, that is 45 degrees radius 1 it is. Here I am drawing a vertical line. 45 degrees radius 1 it is. Here I am drawing a vertical line. 45 degrees radius 1 it is. That is right angle triangle I made. Now this is 45, naturally this will come 45. So it is, if you observe, this is right angled isosceles triangle. So therefore these two parts it will be equal. If this is I am taking as small a, this is also will be a unit. Okay, so if I apply Pythagoras theorem now, a square plus a square is equal to 1. 1 square it is, that is 1. So 2a square is equal to 1. A square is equal to 1 by 2. A is equal to 1 by root 2. So this is 1 by root 2. This is also 1 by root 2. Naturally this coordinate is 1 by root 2 comma 1 by root 2. So I got the coordinates. Again 45 degrees coordinate is 1 by root 2, 1 by root 2. So, and we know cos stands for x coordinate, that is 1 by root 2, sine, that is cos 45. Cos 45 is the x coordinate, that is 1 by root 2. Sine 45 is the y coordinate, that is 1 by root 2. Now tan will be sine by cos, so it is 1, and other things all are is reciprocal. So 45 degrees coordinate is 1 by root 2, 1 by root 2. So all the standard angles values for finding it is easy. One easy method is you remember in coordinates form and then we can write down the values. Otherwise, another method is there. You have to make a full table. One table you have to make out. With help of table also we can memorize, but that will be time taking. So better don't learn by the table method. I will tell you, you remember like in coordinates form. That is 0 degrees. 0 degrees coordinate is I said 1 0. 90 degrees just reverse order, that is we have to just interchange it 0 1, and then 45 degrees just now I made both are 1 by root 2 1 by root 2 1 by root 2 1 by root 2 45 degrees. 30 degree it is I made it as root 3 by 2 1 by 2, and then 60 degree it's a reverse order 1 by 2 root 3 by 2, and always this is x coordinate, that is cos, and this is y coordinate, that is sine, and the corresponding this we can say it as theta. These are the theta. So for example, if you want cos 0 means 1, sine 0 is 0, cos 90 if you want, cos 90 it is 0, cos 45 1 by root 2, cos 30 root 3 by 2, cos 60 1 by 2. The same way with the sine if you want. So you have to memorize only the coordinates. That's the way. See for example, if you want sine 30, so you just bring the coordinates into your mind. 30 degrees coordinate is root 3 by 2 1 by 2. Just bring the coordinates into your mind, root 3 by 2 1 by 2, and sine stands for y coordinates. So then naturally sine 30 will be 1 by 2. Otherwise you have to make the whole table. In the book it is given a whole big table it is given, and you have, for finding one value you have to make out the whole table and you have to memorize it. See, it is better to remember by remembering by the help of coordinates. So just remember the coordinates. So time, first of all you have to memorize the coordinates. It is easy to memorize also. Here 1 0, then naturally 0 1. Just reverse. And 45 degree is 1 by root 2 1 by root 2. 45 degree is 1 by root 2 1 by root 2, and 30 is root 3 by 2 1 by 2, and 60 is its reverse form. So just practice it, just try to memorize this coordinates form. It will be easy for you in future also. This will help you a lot. The table format never will help you in future, since you won't get much time to make a table for doing one simple question. So it is better to remember in coordinates form. Okay, so that is why I explained everything in coordinates format. Now we will do few questions based on this. We'll try to do few questions based on the standard angles. Exercise number 18.1. Exercise number 18.1. First of all, we will do 1/3 part. We have to find the value of cos square 45 plus sine square 60 plus sine square 30. So you are supposed to substitute the values. If you know the values, you have to substitute. See, first of all, cos 45. I said 45's coordinate is 1 by root 2, 1 by root 2. If you have problem, just write the coordinate 1 by root 2, 1 by root 2. Cos 45. Cos 45 is x coordinate, that is 1 by root 2. So here 1 by root 2, its square it is. Then 60. 60's coordinate you have to know it. 60's coordinate is 1 by 2 root 3 by 2. This no need of writing, okay, or just like a 30, this is 60 degrees. 60 is 1 by 2 root 3 by 2, and sine means y coordinate, that is root 3 by 2. So this is root 3 by 2 square. Now 30 degree. 30 degrees coordinate is reverse, root 3 by 2, 1 by 2, and we need sine. Sine means y. See, 30 degrees root 3 by 2, 1 by 2, and we need sine. Sine means y coordinate, 1 by 2. 1 by 2 square. Now just simplification, this is 1 by 2, this is 3 by 4, that is 1 by 4. 4 is LCM, 2 plus 3 plus 1, that is 5 plus 1, 6 by 4, this can be written as 3 by 2. This is first question. Like this, so many questions are in the exercise. Here, just substitute the standard angles values and then you have to do the evaluation. That is only the whole exercise is like these questions. So this is question number 1, third part. Now another sum. Another sum we have to do it. That is question number 3, third part. Again find the values of 4 by 5 tan square 60 minus 2 by sine square 30 minus 3 by 4 tan square 30. We have to find the value of this expression. We have to substitute the corresponding values. That is only trigonometric ratios. 4 by 5 into, first of all, tan 60. So you have to know the coordinates of 60. 60's coordinate is 1 by 2 root 3 by 2. 1 by 2 root 3 by 2, that is the coordinates of 60. And tan means sine by cos. This is sine, this is cos. Sine by cos means it will become root 3. So this is root 3 square minus 2 by sine 30. 30's coordinate is root 3 by 2, 1 by 2. 30's coordinate root 3 by 2, 1 by 2. So that coordinate if you memorize it easy. Now 30 it is 1 by 2 will come, so 1 by 2 square. The square is there. Minus 3 by 4. Again 30 degrees coordinate is root 3 by 2. 30 degrees coordinate is root 3 by 2, 1 by 2. And tan means sine by cos. This by this, so it is 1 by root 3. 1 by root 3 square. So now simplification, this is 4 by 5 into 3 will come, that is 12 by 5. This is 4 will go up, so it is 8, 4 into 8, minus this is 3 will get cancelled, so it is 1 by 4. Now LCM, 20 is LCM, here 5, 4, 48, 20 means here 160, minus 5 here. So now we have to do subtraction. 165 minus 48, 100 and minus 117 by 20. This is the value of this expression.